Hi, welcome to this session on VC models and how to approach VC model design the right way. Modeling is an art form. It is creative. To design and build effective models, the approach is a critical element to get right. So let's begin. First, let me provide some background on who I am and what Radiant Think does. My name is Phil Martin and I am the owner of Radiant Think. Before 1995, I was in normal business roles, mainly around sales and logistics. After 1995, my SAP journey began and spanned most aspects of SAP project support, consulting and training. I've been a subject matter expert on SAP projects, a consultant with Deloitte, an SAP contractor in SD and VC. I've had VC lead roles. I've been a SAP trainer in VC, a SAP system manager, an ERP specialist, and a regular CWG attendee, and in recent years a sponsor. This led me to set up Radiant Think to provide variant configuration training that is unlike any that is currently available. Because I have a VC modeling background, this is embedded in our training approach. Using good practice, good approaches, and innovative learner interactions, we lead the way in providing efficient, cost-effective, self-paced training that can easily solve your VC training requirements. It is aligned to using constraint-based modeling at its core that is relevant both for classic VC and in the future directions on the new AVC. Currently, we have students in countries around the world, and this is growing as companies see the benefit of delivering consistent training to different teams around the world. Many are trying to standardize their approaches and ultimately be in a good position for the AVC. So, what is the right way? We all have opinions on this depending on our journey into SAP. As we know, SAP is famous for having alternative ways to achieve a desired result. VC is no different, and let's just say at this point, there are approaches that are better than others. It is clear that constraint-based models should be the prime approach. Let's see how we can feed into that approach. Today, I have divided up the topic into 5 headings. Call them guiding principles. They are interrelated. They are discover, approach, group, control, and refine. This makes us think like a VC modeler. As mentioned, VC modeling is creative as we start with nothing. And so there is time spent in Discover mode. Discover mode is highly relevant for new models. However, as the business, products, regulations, and customer expectations change, so do our models. So at different points in a model's evolution, Discover is always relevant. So, what are we trying to achieve? I like this photo as it is a good starting point. I call it Discover and Exploit, and we'll see how it applies to VC. Building VC models is one of the few areas of SAP where you start from nothing and build a model that is pervasive throughout the various SAP SAP modules. As such, this means there is a discover phase. In this phase, we are gathering data and knowledge and try to make sense of it. It can be time consuming, and without good practices of bringing it together, it can be an endless cycle. Think of it like baking a cake. We're gathering the ingredients. The goal is that the cake looks good, tastes good, and so for that we need a recipe. Much like a cake needs a recipe, so does VC modeling. The recipe is our modeling approach. It lets us develop VC models faster and with consistency. There is less going round in circles and a more direct path to a solution. We need to follow a set of basic principles. If we exploit these principles, we can leverage the information gathered in the discover phase. Like baking a cake. In VC, we need some tools and equipment. We'll talk about these later. We need the ability to extend or change our recipe in the future. The problem is that the requirements gathering and understanding can be daunting. We need to be able to channel these into a structured approach. It is said that organization and naming are powerful weapons against the chaos within programming. It is also true of variant configuration. In this section, we look at how this helps to guide our modeling. Like a cake recipe, it tells us how to put the ingredients together. We can exploit all the information gathered in the discover phase. The approach we take is critical to bring the requirements together with structure and efficiency. A method I use to organise the requirements is to use this framework. I use this framework in my lessons to explain how business requirements translate into modelling objects. It helps organise the requirements and begins translating them to modelling elements. It is a visual representation to organise aspects of the model. It is laid out to show the relationships of the various objects. We will examine the aspects that are arranged by colour. Firstly, without VC, we have standard SAP master data elements of materials, bill of materials, and routings. Next, overlaying our design is how we use characteristics, classes, and class hierarchy to define the attributes. Not only those used in the model itself, but also to arrange the interface the user interacts with, and as a method to set items in the bill of materials. At the heart of the model is the configuration profile. It determines how the model behaves, such as configure to order, engineer to order, and set processing. It controls the bomb explosion level and is a central container for the object dependencies. Across the bottom are relationships. These can span the whole model from top to bottom. These are typically the requirements collected in the discover phase and broken into the important relationships. Relationships by themselves do nothing. We need controls, often defined in constraints and other dependencies to control other aspects, such as user interaction, pricing, and bomb and routing setting and selecting. Thinking of your model design in this way will make it easier to be structured and organised. Hand in hand with this is naming conventions that we look at next. Naming in VC models is very important. Naming conventions are like signposts in your model. They orientate the modeler and are important if you have more than one modeler or a new modeler being introduced to the models. In the next two slides I show examples. So let's begin with classes. We have different usages of classes in VC models. They can be classes for modeling, sometimes in a class hierarchy, and also as class items in bombs. I use the prefix of N if used as a class node, M if the class is assigned to materials, S where it is a class item in the bill of materials, and L where a class may be needed for a logical purpose, such as being shared across models. Just by looking at the name, you can identify the purpose of the class without needing to drill deeper. The list above is a starting point. Sometimes I add additional class usages like P for purchase. The other key is the class type. The main ones we use are type 300, 200, and 001. By using this naming, we can help ensure class nodes are not assigned directly to materials, can see if a class type 300 has been used as a class item. It makes the purpose really clear. Next are dependencies. I always prefix with what type it is. I know we have icons and dependency types and search fields, but often searching with, say, PR_* is a great way to search quickly or to select items to ALE between systems. Visually, our models look organised, and looking organised is a very good property to have. My convention is very simple. You may have your own, but the important takeaway is to have naming conventions. Often after the type, you may have additional naming conventions, maybe brand, or maybe a purpose such as RT to signify it is used in routings. From here, the approach is combining the framework and the naming conventions to build up the model. The first step is to spend time on a good class structure, identifying relationship across all the requirements and using constraint-based modeling. Often at this point, we may not have made decisions on how many configurable materials we need. What we are doing is getting the underlying structure defined. Class structure is often driven by relationships, so these two go hand in hand. Control is really important. Start with constraint-based modeling as the primary approach before you do anything else. This is your go-to modeling solution, and once you are thinking this way, it is easier to see the solution in terms of constraints. These three steps promote integrity and consistency. With variant tables, you're separating data from the code. This makes model changes a data exercise and not a coding change exercise in most cases. Use constraints before considering procedures. Procedures run and can be hard to debug. Here are some golden points to remember. Avoid preconditions. Use constraints to filter values. They're more forgiving when users make changes, easier to debug, and using naming signposts that are easy to find. If you feel tempted to use local dependencies, then don't. They are offered as a solution, but should not be used and will be depreciated over time. Reduce long procedures. They can get unwieldy and be troublesome. Also, they do run many times. VC modeling is, at its core, about organizing data into groups. We group data into relationships. We group components into BOMs and subassemblies, and we group characteristics into classes or groups in the user interface. We group production processes into routings. In today's world, everything is driven by algorithms. We see it in face recognition, license plate recognition, and many other areas. For example, sorting a pile of Lego could require grouping into colors or perhaps shapes. These algorithms can be thought of as a framework to process this pile into some sort of logical result. Gathering requirements can seem like a pile of Lego at the beginning. Many colors, many shapes, and complex ways to assemble them together. So, for example, an algorithm may identify all yellow Lego. In approaching VC models, it is similar. A high percentage of the model design is about grouping. It is breaking the requirements into smaller pieces, to take the noise out of the data and start seeing how it can be put together. We identify relationships in the data and from other requirements, and so our grouping begins. There are four main groups that typically apply in VC model design: class structure, data relationships, BOM structure, routing structure. Our VC modeling mindset should always be looking at how our models can be modular, plug and play, flexible, scalable. If you get this right, then it is easier to adapt the models to future changes. Let us now consider class structure. A simple example from my VC Essentials course, in the section on classes, characteristics, and class hierarchy, we created a class hierarchy to organize the product families. A class hierarchy provides structure to a VC model through inheritance. This is useful for model integrity as it ensures consistency in key data. Look at the naming signposts. We can immediately see that the classes assigned to the materials, M, and those that form part of the hierarchy, N. Let's talk about plug and play. Often it is possible to make your VC models plug and play. What do I mean by this? Rather than always needing to create aspects of the model over and over, in many cases it is possible to reuse them. At the window company I work at, we used a concept of plug and play. We can reuse the same assembly over and over in the super BOM. This reduces coding and ongoing model maintenance. These assemblies are part of a multi-level VC model, and they also contain significant VC logic. Create once, reuse many times. In many cases, we use the same subassemblies in multiple models as well. Lastly, and very importantly, models should be flexible and scalable. If you apply the approach outlined so far, then often this will result in models that are flexible and scalable. One key method to make models flexible and scalable is to use variant tables to store the relationships. If a new variation is required, it is a simple matter to maintain the variant table data. In this example, again from the window company, we have many variant tables that control key settings. A huge time saver has been the ability to bring in a new window design by adding data to tables and without, in many cases, updating any code. The other benefit has been incorporating new modeling requirements that have come from left field. What I mean by this It is that often models need to adapt to requirements that are not known yet. We have found our well-structured models at the window company in many cases made the incorporation a lot easier. Control is about putting our rules in place to make sure the requirements are implemented in a controlled and efficient manner. The approach we take for this is fundamental to our VC Essentials course. So let us look more closely at this. When I think of control, I think of constraints, and you should too. It is very clear direction of SAP and the new AVC that constraints are front and center. The AVC, at its core, is a constraint-based modeling engine. Constraints are a beautiful thing. They support the concepts of being modular, plug and play, flexible, scalable. In this example, again from the window company, look how we apply this. We have naming conventions, groupings using constraint nets, and a model that looks well structured. You can see patterns in the naming and how this helps signpost the models. This makes it easy for a modeler to find what needs to be changed or added to a model. One of the constraint superpowers is the filter on filter. Often complex requirements, when broken down into its parts, fit really nicely with constraint logic. This is because we can isolate a requirement into a constraint and place these constraints into a constraint net. Let's look more closely at the filter on filter and step through a simple example. On the left is a characteristic with 7 values. To the right there are 3 constraints, and as each of these becomes relevant, e.g. the condition is true, the list will be seen by the user to filter down. So let's have a look at this filtering. In this case, it filters down to value equal 1, because that is the only common value that is determined by the 3 constraints. Briefly, let's discuss constraints and procedures. You can see I am emphasizing constraint-based modeling, as to me it is important. However, it is easy for modelers to revert to procedures in many cases. Procedures do have their place, but we need to be cautious in overuse. Initially, constraints can be harder to learn. This is often because they look difficult, when in fact they are quite easy. In our VC Essentials course, we teach constraints first, before any other object dependency type. But once you start using them, then you won't go back to procedures unless you need to. There are cases where you need to use procedures, such as defaults and in bombs and routings, as that is the only way. Let us look at the pros and cons. Constraints only run when their condition is true. Think performance gain here. We have seen they are modular, and so are easier to manage and maintain. They are powerful, as seen in the filter on filter as one example. Complex requirements can be modeled simply. Procedures are run many times, as there is not a condition to turn them off. They can be hard to manage because they can be long and complex. They can terminate, and that can be a bit invisible in LOVC, while in the AVC it will step over the termination. When reading variant tables, they only consider the first value as alternative. So now let's move to the last section. The refine section is about how we get models up and running. A good approach when developing models is to use an agile approach. Let's look at that now. When you have defined the basic structure, class structure, bomb structure, routing structure, constraint structure, you are ready to begin the model build. Prototyping is important. Initially, it is used to confirm the structure of the design works as expected. Often 80% of the requirements can be modeled with 20% of the total effort. Introducing the more complex requirements or additional requirements that were not known at the beginning can require 80% of the time. However, if your model design is sound, it can make this task quicker in many cases. The takeaway here is to incrementally build and modify new models to ensure your design is sound. Thank you for watching this presentation. Try to cover fairly concisely what I think are the important aspects of approaching your VC model design. If you have any questions, you can email me at phil@radiantthink.com.au. You can look at our website. You will find us on YouTube and in LinkedIn and Facebook. So happy to answer any questions you may have. Thank you.